capacitor is a dielectric sandwiched between two parallel plates, and this is a capacitor and it is connected to a voltage source via a resistance and a switch. So the voltage source is a DC source of voltage V, and let's say this is R and this is C. When the switch is closed, immediately after that, positive charge gets deposited on the upper plate and negative charge on the lower plate. So there is this electric flux density, electric flux basically, as a result electric flux density and corresponding electric field. Now when the switch is closed, instantly the charge storage is not an instant process, so it takes a while, and the electric flux also keeps increasing, and the electric field and electric flux density keeps changing. So because of that, there is a current through the capacitor initially, and when the capacitor has when the charge is stored, its total charge is stored, and capacitor capacitor has the voltage V across it, then the current stops for a DC source because there is no more change of electric field across the capacitor. So Q, the stored charge, is proportional to the applied voltage, and the proportionality constant is C, where C is the capacitor and it's given by the expression permittivity. It's related with the permittivity, the material property and dimension. So permittivity is of the dielectric material times the cross section of the area of the parallel plate, and D is A over D. D is the distance between the parallel plates. So that's C. So if we talk about the current, we can say dq over dt, the change of charge, which is the definition of current. So rate of change of charge. So this one will be C dV dt, or C is epsilon A over D, and V we can write dE over dt times small d. So voltage is equal to electric field times D. That's why I have replaced the electric voltage with electric field. So this D gets cancelled. So this is A dE over epsilon times A times dE over dt. So change of electric field times permittivity times A. That's the current. Now if we recall, the electric flux density D is equal to epsilon E. So what we could write is A times change of electric flux density. That's the current through the capacitor, and this is called displacement current. Even if we look at Maxwell's equation, we can see the electric current density, the displacement current is given like that. That's in terms of current density. So that's dd over dt. But we have multiplied here, we get the expression here as multiplied by A, the area of the surface parallel plate. That's because we are calculating the total current, the total charge. We have used Q here. That's why we had to have the total. We got the total current basically. So this is the current through the capacitor, which is actually due to the change of the electric field. And when we have an AC voltage source replaced by replacing the DC voltage source, what happens when the supply voltage is an alternating one, then the electric field keeps changing, keeps alternating, electric field in the capacitor. As a result, there is always a current. So we have a current when in case of an AC voltage through the capacitor, but when it's DC, initially we have a current which is like this, and once the voltage across the capacitor attains the supply voltage, then it acts as an open circuit in case of DC. But in case of AC, it will keep alternating because the voltage will keep changing, so the electric field will keep changing. As a result, D will keep changing because E will keep changing, and E is changing because applied V is changing. So there is a displacement current in the capacitor, but this current is because of the change of electric field. So that's how we talk about the current through the capacitor. So I just wanted to discuss this